Hello, Flat Earth researchers, debaters and debunkers. Celestial objects reflected on bodies of water prove that perspective is at play when we observe the sun, moon and stars travelling away from us, and that we are not on a spinning ball Earth. In a minute we'll look at pictures of the moon and stars reflected on lakes and ponds, which prove that perspective is what we are seeing in those reflections. But first, let's establish what we are looking at with these two images. The one on the right is the moon setting across the Andaman Sea, and the one on the left is a pond with lights on the other side. We can see in both of these photographs that the lights are reflected on the surface, and we know for sure that the surface of the lake is flat, and it definitely looks to us like the surface of the sea is flat. In fact, we know that if any of these surfaces were curved, they would act like convex mirrors and they would distort the reflection, making it bulge like we would see in a hall of mirrors. We also know that when the reflective surface is very calm and flat, without the distortion of ripples or waves, we would see a circular reflection. But in both these scenarios, we have movement on the water which distorts the reflection and makes it longer. And in both these images, we have a horizon created by the surface, just a short distance in front of us. In the picture on the right, the horizon is created by as far as we can see across the surface. In the picture on the left, the horizon is created by the embankment on the far side of the pond. And when we look at the row of 3 lamps close together on the opposite shore, we see perspective at play in the actual lamps and in the reflection. We see the lamps, although being the same height as each other, appearing to get shorter and closer to the horizon over a very short distance. And we see the same thing in the reflections of those lamps. We can see at least 2 of those lamps reflected in the water, and as they get farther away from the embankment, we see that the reflections get closer to the embankment or the horizon created by the embankment. And we can see exactly the same phenomenon in photographs of the moon reflected in bodies of water. So from these observations, we can keep in mind that something in the sky said to be hundreds of thousands of miles away or even millions of miles away simply would not be reflected in bodies of water right in front of us. This photograph of the moon reflected in a pond or a lake is an excellent example of how perspective works and allows us to judge distances and gives us some kind of depth of field. We know that this photograph is a 2-dimensional representation of a multi-dimensional landscape. Here we see the trees on the embankment reflected in the water, and those reflections are about the same size and height as the actual trees. But when we look at the apparent height of the moon above this tree here, we see a very large gap, but when we look at the reflected moon, we see that it is almost sitting on top of the tree, the reflected tree. So this simply tells us that the moon is farther away than the tree. We know the tree is right there on the embankment, but due to perspective that is reflected on the water, the moon is further away and therefore appears closer to the horizon that begins here at the edge of the water. In this picture we see a similar situation. We have the moon high above the actual trees, but in the reflection we see the moon is much closer to the tops of the trees that are reflected. But another proof that perspective is what we are seeing here is this star here, just on top of this tree, apparently, due to our perspective. However, you look at the star reflected in the water, and we see that it has come down a lot more and is reflected near the bottom of this tree. So this tells us that the moon is closer to us than the star. The star is farther away. Of course, in a 2D representation, there is no way we can tell any difference in the distance between us and the moon and us and the star. But the reflection tells us that because the star is closer to the horizon, that is the horizon where the mirroring of the landscape starts at the embankment, this means the star is farther away than the moon. Another proof that we are seeing perspective is that if you measure the distance between the moon and the star here, and the distance between the moon and the star in the reflection, they are the same. We can also look at, if we formed a triangle with a right angle underneath the moon going to the star, the length of that triangle would be the same. However, these two objects are further away than the trees, so they are lower down in the reflection, or closer to the horizon of the reflection. And in this image we see the same thing again. We see these trees which are back from the embankment reflected in the water, and the apparent height between the trees and the moon quite significant, but here we see the moon nestled on top of the trees that are reflected in the water. If these trees were any further away from the embankment, they just would not be reflected in the water. So again, this leads us to contemplate what we are really seeing when we see a moon that is supposed to be 250,000 miles away, yet it is reflected in a pond right in front of us, in which things not very far away will no longer be reflected. Food for thought, I hope. Thank you very much.